So, all right. Well, glad we're able to get popping into some solid questions here. I'm Dan Faggella. I run Emerj Artificial Intelligence Research. We help large organizations with their AI strategy and selecting high ROI projects. And one of the cool things that we get to do as a market research firm is work not only with big organizations and legacy industries, but work with hot startups. And today, I'm lucky enough to be with Peaxy. And Manuel, you and I have a bit of a relationship as you were on our podcast, the AI and Business podcast, a number of months back, which was a fun episode. And I'm glad to be able to continue the conversation a little bit forward as well. So with me today is Manuel Terranova, who's the CEO, president, co-founder here at Peaxy. And John Ervin, who's the chief scientist, is also with us for the conversation as well. So we're going to go through about 30 minutes of kind of Q&A. After that, we'll have maybe some other open-ended questions, stuff that's been submitted. We can drag through maybe some of the other curiosity points that folks have. And we're going to get technical. We're going to dive into this idea of battery analytics, this domain that you guys probably know more about than almost anybody. But Manuel, I wanted to start with a bit of an icebreaker here. I know you and John actually kind of go back beyond just working together on this tech. You guys know each other from a while. You want to tell that story a bit of how you two connected?
So John and I met freshman year at college at Cornell, and we had obviously four very formative years together as undergraduate students. And then I have to tell you, you fast forward 30 years and you're juxtaposed at the Pentagon or at some highly secure military facility, and you're sitting next to your freshman year roommate, and things get pretty surreal, actually. So it's a lot of fun to have John with me. It makes the experience of running a startup much better, much more enjoyable.
That's cool. That's cool. Yeah, I have to say that's one of the prettiest campuses I've ever been on too. I think Cornell's obviously fabulous institution, really cool place. Must have been formative years indeed. And now you guys are working on some interesting stuff, as you mentioned, Pentagon. Today we're going to be talking about battery tech, and we're going to be getting into really, as far as I can tell, the business value of this stuff, what people need to know in order to drive value in their companies. And I think it starts with data. Data is what you guys work with. Data is what you can explain well. I heard you do that on our previous interview, which is why I wanted to get a little bit more into the meat and potatoes there today. I wonder if you could draw kind of that direct connection between high quality data and analytics to business value. Why is that such a straight line, and what do business leaders have to have click if they actually want to unlock value in this battery space?
Well, for starters, if you want to query your data, the data needs to be in a sufficiently organized state of affairs in order to monetize it. And that's generally where we start the business dialogue with CEOs of battery companies. The attractiveness is, of course, to run machine learning algorithms, to do AI on battery data, to get to really, and I'm sure we'll talk about it later in this podcast, talk about really innovative things that we can do to provide accretive revenue to customers. But the dialogue when we walk into the room, we sit down with the CEO, always starts with, we have to get data hygiene into your business. We have to get the data sets parameterized. That is, you have to model the data. And then we want to apply smart algorithms on an ongoing, continual basis, not in an ad hoc fashion, because that just has proven over and over again to get very frustrating and very costly for people. So generally, our discussion starts with state of the data landscape. Is the data parameterized? Can we query it in a way that we want to? Has it been sufficiently aggregated? And then once we get past those initial hygiene steps, then John and the others are able to actually go in and compute some very interesting outcomes.
Cool. Yeah, and I do want to get to those outcomes and talk about the tangible value here in ways that the folks that don't have John's PhD might understand. I'm certainly one of those folks, so I'll be learning with you. When you talk about sort of making this not ad hoc hygiene and sort of data engineering, if you will, but a real system, part of the bedrock of the company, turning this into something that they do. There's cultural change there. There's dealing with legacy systems. There's a lot to sort of make that a real fundamental sort of shift for folks. And it's I think people often maybe underappreciate how much heavy lifting goes into getting that done from a firm like yourselves. What's important to get that click to happen where people can actually invest in this data infra and hygiene in a more systematic way? What does that require?
When we get into a boardroom where the board recognizes and the senior leadership recognizes that the data is an asset, and that being a battery company that is not in control of its data is going to lead to a weak competitive situation in the market landscape, that's a customer we want to work with. So in short, where the CEO and others recognize data as an asset, that's a good fit. Where we struggle more is where people want to underestimate the effort and the lift required to get their data into a reasonable form. By the way, this picture is something I use
Let's talk about
to lead off our discussions with customers. And customers think about the fourth bullet on this continuum, which is the machine learning and analytics.
Yeah.
And everybody wants to jump right to that step. And of course, we spend a lot of time educating customers on why their battery data is extremely valuable and why it needs to be organized in how it's captured, in how it's shaped and curated, and how it's managed for the long term, how it's parsed and data modeled, so that the machine learning and analytics can actually happen on an ongoing basis. And John, I want to make sure you get your words in as well.
Sure, Manuel, Dan. So how do you drive value? How do you draw these lines between ones and zeros and things which matter from a business context? Well, I'll explain that with, perhaps the most prevalent example from what I'd call the integrator persona. Now, we deal with various personas. We'll talk about that a little more as we go on, I'm sure.
Yeah.
But the integrator, these are the folks that don't necessarily make the batteries, but they buy the batteries from OEMs. They deliver then systems to customers who operate these systems on the grid. So the person who buys these batteries, the grid operator, wants a warranty from our integrator that lasts 10 years, maybe longer, right? So how can this integrator guarantee the value that they're getting from their battery system when we all know batteries in the cell phones last 3 years, maybe, right? Batteries in the Tesla, we don't quite know. Are they going to last 10 years? Maybe, maybe not, right? But these integrators now, they'll take 2 years, sometimes less, of laboratory data, and they need to do extrapolations from this laboratory data in order to draft those contracts, those warranty agreements with the system operators, right? So that system operator agreement, the warranties for that system operator need to have very, very secure terms for the system operator. Otherwise, they're not interested. So now they have to balance as the integrator, do I make the warranty too tight, in which case I might suffer liquidated damages because I don't meet the terms, or do I make the battery warranty too loose, in which case I lose the deal to another integrator?
Yeah.
Right? So it's a very complicated process. Complicated even more. It's not just that we have 2 years of data on one hand and need to extrapolate it to 10. The conditions for those 2 years are not at all representative of the 10 years on the grid.
Yeah,
right?
yeah.
Of constant charge, discharge, which is how many of these OEMs test their batteries, doesn't equate to the grid where you have transients, where how you're using these batteries might not only be charge and discharge, but might be frequency regulation exercises and the like. So it's a complicated process that needs to involve a lot of physics to understand how these batteries operate, but at the same time, a lot of data, right, to inform those physics so that those warranty agreements can be made robustly.
Got it. Okay. So yeah, we're getting to the nitty gritty of the ROI, and you're right to say there's a lot of moving parts here. So I think it's I'm glad we're getting into this. I want to get a little bit more nuance out of this point here. So one clear facet is if we're going to make guarantees and we have to compete in the market with those guarantees and also deal with the financial consequences of them, we want to base them in what we can deliver, and we want to feel good about what we can deliver, and we want to know we can do that. And what you're getting at is that extrapolating from that 2 years of data is by no means a solved problem. I mean, people, we've got to be able to do that well, and it's really hard, and doing it better is what's going to allow us to get to better business outcomes here. I imagine on the grid, we're also potentially dealing with, you mentioned the lab is not representative of how it'll be used in the world. There might be temperature considerations or all kinds of other factors, right? That they just couldn't possibly pull out of these things sitting in a lab somewhere.
And that's right. And that gets to Manuel's point of these analytics need to be done dynamically, right? So we have customers and we speak to these customers. They gather 2 years of data from the OEM, and these are large data sets, right? These aren't, 10 megabyte data sets you're passing along by email attachments. These are things that need to be transferred on the cloud, need to be analyzed very carefully and very subtly, right? But then they do that analysis, and then they might take that analysis and write, and we spoke to some folks quite recently where they just take this analysis and write a MATLAB algorithm, and they will put this MATLAB algorithm into their actual firmware to give you a state of health from the firmware, right? But that's algorithm doesn't change, right? So here we have this algorithm that we made with our data scientists, took a lot of dollars to fund the data scientists, to fund the OEM research, and it just doesn't change, right? So we need to dynamically adjust that algorithm to account, Dan, to your point, to temperature changes, and also to account to how the voltage spikes that are coming through the grid system that might not be properly isolated from the batteries themselves, BMS degradation. And we see that across the line. You see 4 personas on your screen here. Each of them struggles to how do you understand battery degradation. They struggle for different reasons, but these batteries don't last forever. We all know that from our cell phone experience. So to study their degradation is key. And to do that, you need data at the beginning, and you need data in the middle, and you need data at the end.
Got it. And so I'll ask you first, John, and then I'll pass it back to Manuel. This topic of seeing your data as an asset. I think different industries are maturing to this idea in different speeds. I think that, if we go into, fintech or e-commerce or something, I think it's relatively well understood that, well, yes, of course, these kinds of activity data and customer data and promotion response data and whatever, that this is part of what's going to give us a sustained advantage. The battery space, obviously their data is an asset as well, but it might not be as well understood to, let's say, your average leader in these firms. In what other ways does data sort of provide the sustained kind of asset value where, like, hey, this is going to be what differentiates us in the market? One thing is the predictability of degradation. If we can do that better than others, we can win more deals. We can not bid on deals where we can't fulfill the promise. That clicks for me. What are the other areas where the word asset really is the right term for data in this space?
Yeah, so Dan, I'll mention 2. Great. So let's imagine you've got yesterday's technology on the grid. You've been using it for 5 years, right? You'd like to replace it with today's technology. And by that, I mean typically chemistries, chemical flavors of lithium ion. For instance, NMC is a technology which could arguably be called yesterday's technology, though it's still being deployed quite readily. Whereas LFP is kind of today's technology or tomorrow's technology, right? So you have a lithium ion NMC installation. You've used it for a while. You'd like to repurpose it, right? So how do you price that system for repurposing? Right, so you use your data. Your data is an asset which drives purchasing, which drives pricing of that asset for repurposing purposes, if you will. So if I know how I've degraded over time, I know how to model degradation in the future, I know that I can put my battery installation in a lower value use case than I had previously. I can use data as an asset for that, right? And the other is safety as a service. I'm sure many who will listen to this are aware of the many fires that have broken out in South Korea from their lithium ion farms. There was a pretty well publicized fire in the Arizona area. This was in 2019 that actually unfortunately injured a few folks from an installation there. So it's not enough to just simply understand our battery data from a perspective of how to maximize dollars. We also have to minimize safety risk, right? So data as an asset there can be used in a safety as a service paradigm whereby piece of software now can turn on and off battery installations based on safety concerns as well as for economic concerns.
Okay, got it. So that's one more way where if we understand the patterns, the where, the risks with this kind of technology and this kind of an installation, we can add value, in this case, not by necessarily doing something new, but even just the ability to just turn off, just reduce risk. If that's baked into our tech, that might be a sustainable advantage. That might be why we get picked over somebody else. Is that right?
Correct.
Got it. Okay, cool. Manuel, I know you've got a take on this, and I want to maybe get your perspective as well, if there's anything you want to layer on top of John's insights about this idea of making it click, data as asset in batteries. Anything you want to make sure people get?
It does depend on the persona. So, we've had discussions with folks who want to do battery leasing on large scale for electric vehicles and mobility purposes. So for them, they're acquiring a large fleet of battery packs, obviously computing dynamically remaining useful life, which you could say is a derivative of degradation, but remaining useful life is essential for any leasing business in order to run that business properly. So in that context, the CEO and the leadership team are going to understand that the battery data is a massive asset for enabling the business model. In fact, one of the reasons I don't think leasing has fully taken off yet in the battery space is because remaining useful life computations are pretty demanding. And without a good idea of what remaining useful life is going to be, you can't value the residual value of that battery pack. And that makes the leasing business model really challenging. So that's a really practical example. Warranty management is the other one. Everybody's caught in a pinch here. All the personas you see here test batteries. But the reality is every battery company that we've talked to struggles characterizing the performance of their equipment in the field. And no matter how hard you try or how exhaustive your battery testing regime is, what we're finding is real life practical use really has little to do with what was tested in the lab. And that white space is a huge challenge. And obviously having the data life cycle of the battery to understand how your battery is going to perform in scenarios you haven't even contemplated yet is a huge competitive differentiator for a battery company or an integrator or a battery R&D shop. It doesn't really matter. So this issue of how do you characterize batteries under certain customers' would-be conditions is a huge selling point. And there's many battery companies that simply struggle to assuage your customers' concerns that the batteries are going to perform in the customer specific locale with those specific ambient conditions, with those specific grid conditions. And that's where people fall down when they don't treat data as an asset.
Yeah, I mean, that's a borderline unsolvable without ML on some level kind of problem, right? If we're talking about those infinite combination of ambient factors in this, temperature environment and the seasonality that happens there and whatever else is going on, how it's being used and what intensity, prediction clicks for me as a big value there. And this sort of steers us into another topic, Manuel. I guess I'll keep you on this one and then pass it to John, that we lightly touched on in a previous interview, this idea of kind of crown jewel data. We're talking about data as an asset. There's some data that's just more valuable than others. It's going to be the linchpin between a winner and a loser in terms of a company and a market, et cetera. You guys double down on this as a theme. This probably varies, just like your last statement, to the persona, I would imagine. So maybe you could touch a little bit on how we can really define crown jewel assets, and maybe the listeners will think about how to prioritize the data that's most important for them. That's what I'd really like to get out of this question.
So, and I've got a picture here I want to use to support the answer, Dan.
Okay.
So let's talk data for a minute.
Cool.
Two fundamental types of data: unstructured data and structured data. Structured data lives in a database. In the battery context, that's a bill of materials. That might be pricing information. That might be warranty parameters captured in a database. That might be your manufacturing execution system, which is capturing data about your batteries as they're being built, or your formation testing station where battery test data is being captured. That typically lands in a database construct, structured data. More difficult files are unstructured. And the crown jewels there are geometry, simulation, and telemetry. Telemetry in many cases is a bit of a misnomer because people consider that partially structured, and that's probably a fair characterization. But the point is, if you want to get predictive about batteries, you have to thread those crown jewel data sets together by serial number. And that's because batteries are fickle. Batteries are uniquely serialized. No two batteries coming off the line are the same, although most people would think that they are. But electrochemistry is tricky business. And so how that battery gets tested, how that battery gets shipped, the kind of vibration regime it's being subjected to while it's en route to final destination has a significant impact on longevity and degradation. And so we are firm believers that to do this right, to get predictive, you have to thread these crown jewel data sets by serial number. And that's a prejudice we've brought into the space just because we've been dealing with industrial equipment as long as we have, to know that no two pieces of industrial equipment, including a battery, are the same.
Yeah, man, I say it all the time, but the folks who operate in machine learning in the purely virtual world, you run an online store, you just have it so much easier than you realize. The people that operate in the physical world, we've got all these other considerations. There's so much value to unlock, but there's also so many new challenges. Maybe John would be able to help us kind of talk about this idea of threading. Clearly, there's a number of different kinds of super valuable data. The way to make them work together really well would require a pretty robust background in the technical side of this stuff. But you guys have to explain this to maybe some of the non-technical leaders as well. John, if you wouldn't mind, maybe anything else you want to add to this idea of crown jewel data that Manuel helped us tee up, and then maybe a little bit of nuance on making that threading and that kind of coming together at the serial number level work.
Sure, Dan. Yeah, it's funny. We think of batteries as rather simple devices, right? We've been putting AA batteries or C batteries in our toys since we were little boys, right?
Yeah.
Just two terminals, plus, minus, what could be simpler, right? But the issue is that each of these particular batteries stores such a small amount of energy and thereby puts out such a low value of power. They need to be built up in very large structures. And these structures themselves have switches that need to be turned on and off at appropriate times. And you end up getting an explosion of data from these very simple two-terminal devices because they're built up in complex structures to make them appreciably valuable on the grid. So that's the first thing. It's very different, and the amount of data that you get per kilowatt hour or per kilowatt is very, very different than you would get in, say, the wind farm, and we've worked in there as well, or in thermal power generation, that is gas-fired power plants, coal-fired power plants, and the like. So there's quite a bit of data. And really, it's hard to say that it's just a small amount of data that's important. It's all important. And it is very important to thread it by serial number because you do find that the batteries in the geographic extremes of any particular instance behave quite a bit differently than those in the middle because they are very susceptible, particularly lithium-ion flavors, to thermal effects, as many of us know, sometimes quite famously. But to be fair, there are also other approaches that people are taking that aren't ML, believe it or not. I mean, there are companies out there that believe that what you should really do is take batteries out of your system, do a tomography exercise, essentially take a CAT scan of your battery, take data from that and put it back in the system. And some of that is being done on the manufacturing line, less of that's being done in the actual field, though there are proposals to do that. But even there, the challenge then is to take this data, like a image or a 3D image of the actual battery, an X-ray of the battery, extract features from it, and then associate it to where that battery was, right? Where was that battery in space? Where was that battery in time? How was that battery used historically, right? So that's actually a non-trivial problem when you start getting mixed data sources, as Manuel was pointing out. Right, it's easy enough to just take time series data, as we call it. The voltage and the current was this at this particular time for this particular serial number. But it's when you now need to superimpose that upon how the batteries were used, their dispatch curves. You superimpose that upon maintenance use that was done. And to bring this data together to get a holistic picture is a non-trivial exercise that we at Peaxy do with our data science team. So all of it's valuable, right? All of it is valuable. All of it can go into algorithms which are either machine learning based, fully physics based, or most often semi-empirical based algorithms in order to get a holistic picture of how the battery system is working.
Got it. The analogy that leaps to my mind as someone who doesn't write the Python is on some level that of diagnostics and healthcare. It is hypothetically possible to get some value out of simply training an ML model on identifying some kind of lump or structure in a lung for lung cancer, let's say, in a chest X-ray, and using that alone. But ultimately, where the tech is going is we want to understand maybe that person's genetic history. Ultimately, we want to understand maybe their health history. You mentioned like time series data. Ultimately, it needs to be layered into context for us to really be able to say something specific about this person. It sounds like what you're saying, and let me know if this is the wrong analogy, John, is that in the battery world, it's also very hard to take one slice and say that this is going to be predictive. If we want to make our leases and our warranties and everything else as accurate as we can, we want to understand degradation and be able to predict and deliver based on that. we've got to have these things looped together in a similar way. Is that safe to say?
That is, Dan. And it's not just the history of the battery. It's also, you have to take these models and extrapolate them forward with hypothetical use cases, right? So if I'm going to use my battery, it's very simple to understand the battery use case of load shifting, right? We've got a series of photovoltaic panels, right? Of course, the sun only shines during the day. So we charge the batteries during the day and then we discharge them at night. That, as simple as it might sound, is not the typical use case for batteries. That represents only around 20% of the battery use cases today. A more typical case is something called peak shaving, whereas there are times during the day where power is expensive, and those might be during the sunshine periods of the day. And we use batteries, which may not necessarily be charged with green resources, to decrease the cost of the most expensive parts of the day. You would find this in, for instance, if you were to have a manufacturing plant that would have a need to use a very high power piece of equipment, instead of have the utilities place very large amounts of current into the facility, they would have a battery in a microgrid that would service this pulse of need for power, if you will. So this idea of peak shaving is actually a more typical use case. And so how these batteries behave in the past in a load shifting use case would not necessarily predict how they would behave in a peak shaving use case, right? So, there are analogies in healthcare as well, right? Our lifestyle as we age is of course different than our lifestyle going forward, but you have to go forwards and backwards in order to do these calculations in order to maximize the economic value from any particular battery system, and all of it needs to be informed by very large amounts of data. So yes, there are very similarities in this longitudinal study of healthcare which you're describing, that takes large amounts of data sets and bring them to bear on particular problems. And it's a complicated problem. As you know, it's not solved in healthcare and it's not solved in batteries.
Definitely not. But at least we're getting closer and getting to some of that predictive value we want. It sounds like one of the nutshell things I'm taking away here is that not only can we sort of, look at our historicals and maybe say, what does it look like if we continue doing the same thing? What you're saying is, hey, if we switch into this mode of using this battery, or we switch into, this type of use case, what's going to happen to my resources? And to be able to predict that and know, hey, this thing is going to hold, or hey, we need more of this kind of battery or less of this kind of energy if we make this change in our setup. It sounds like maybe that could allow us to better use the resources we have with confidence. And this feels like it's a big part of the ROI, if I'm hearing you right.
That's right. That's right. And of course, we're just addressing this for the integrator and operator personas that we described previously. Yeah. For the folks in R&D and manufacturing, they're using data for very different things, right? The folks in R&D are trying to use the battery data in order to drive their processes forwards as new technologies come to bear. Right. So in their particular case, they're not necessarily trying to do the extrapolation that we're describing, but they're trying to do bring many, many different types of data to bear in order to drive a process forward based on optimization of things like the amount of power I get per unit mass, the amount of power per unit volume, the amount of power per manufacturing cost, and so forth. So yeah, your understanding is exactly correct, but just to be clear, it's different for different personas.
Yeah. That has been clear for pretty much all of your points here. What's crown jewel assets, et cetera. It's really going to depend on what value are you looking for? What are you doing with this stuff? I see we've got some stuff on screen. I've got one last question in our last 5 minutes or so until we open it up to the more broad questions, but I want to make sure we can touch on anything insightful that we should touch on here. Manuel, is there anything you want to dip into to maybe layer some value on top of what John had mentioned?
I would just say that a lot of battery customers are asking us about intelligent dispatching. When we think about monetizing, I consider intelligent dispatch kind of the apex KPI that people.
Okay, this is good. Let's double down on this. Talk to me about how you frame this and why it's so important.
Well, it ties into what John was saying. If you want to do intelligent dispatching, you obviously want to be able to repurpose your battery farm for different revenue generation ideas. And that requires a lot of what if scenario planning, because you don't know what the degradation on the battery is going to be if you don't have the ability to model the degradation ahead of time.
Yeah.
And so the people who are underwriting these projects are not going to let you kind of willy-nilly dispatch into different revenue modes for your battery farm unless you can demonstrate that the model predicts that degradation is acceptable and that the revenue outcome of this action is going to be profitable. So to me, energy management systems and intelligent dispatch put a nice cherry on the sundae and kind of thinking about all the things that have to go right to really monetize your batteries most effectively. And so that's a use case I think is we're spending a little bit of time on.
Yeah, intelligent dispatch. So, when you said it, I guess what I thought, what immediately came to mind as a bit of an outsider to the very narrow and niche area of batteries was, when will I need more and of what potentially? So we don't want things to break down, but I also don't want to have a warehouse full of spares just because I don't know when they're going to break down. This
Right.
like it's of paramount import, no matter what the use case is for the battery. When do I need a new one? When is this stuff going to run off? That's what I heard about intelligent dispatch. You seem to also be using it in the kind of intelligent repurposing. Maybe that's also a mode of dispatch.
Yes.
Do you apply both of those there?
So dispatch would traditionally be interpreted as telling the battery whether to store the energy or to sell it back into the grid.
Okay. Okay.
And that decision seems very simple, but of course, you can get incredibly complex in determining when that switch should be or should not be thrown. And to me, it's the highest order that you can achieve with a battery farm is to be able to do intelligent dispatch across multiple revenue, multiple monetization use cases, as they call stacking the revenue opportunities is how the literature refers to that. And so like John talked about load shifting, well, what if I want to do peak shaving? What if I want to provide batteries for black start? What if I want to do frequency regulation? All these scenarios require some level of intelligent dispatch. And that is where, obviously data is an asset, parameterizing the data, having it threaded, and understanding how those batteries are going to perform in that particular customer's locale all comes together to help that customer make money.
Got it. Okay. Yeah. And it's almost molding a picture in my mind here, and we'll get into some of the other submitted questions in a second. But the picture that comes to mind is almost this idea of, in the world of trading and wealth management, the bigger firms all have some level of really highly refined automated ways of making some very common decisions. Not all of it, and clearly sometimes there's errors there, but those bigger firms just have a natural edge and are able to, in some degree, kind of keep their position because they're just able to optimize all those circumstances. I'm almost imagining a battery future where the folks who can repurpose and pivot and be making money with their resources at all times are just market winners, and the folks that can't be nimble are not. It's almost, I don't know, it's like automated trading analogy in some way.
It's well said. They're market winners, which means the other battery companies are market losers.
Yeah.
So it's not good enough just to be a battery company these days. You really have to bring the data to bear in order to get to these higher value services like intelligent dispatching. The other thing I'll mention is that people overlook in the battery space, Dan, is that there's no chain of custody for the data of the battery over its life cycle. If you're United Airlines buying a turbine for an aircraft, there's a chain of custody of the data for that turbine from inception and design all the way through when that engine is retired. In batteries, as the batteries come out of the factory and they're dispatched into the field, often you have a chain of custody event that's broken. And that creates special problems for integrators and for people who are actually operating the batteries. And that's something also that probably needs to be underscored in terms of data as an asset, is that generally in batteries, you find the data set gets severed, and the people who are operating the batteries in the field don't have, let's say, formation test battery data available for those assets. And that's a challenge we also try to help with.
Got it. Okay. Do you see that being something that shifts as this world comes to understand how valuable data is? Do you think there will be maybe cultural shifts in kind of how we work, where those kind of skips and gaps are not going to be seen as acceptable to companies in the same way as maybe they are today?
That's certainly what we're banking on. Peaxy is here to reconcatenate that chain of custody. And we spend a lot of time with battery cyclers because that is the beginning. That is the source for a lot of battery data. I want John to talk a little bit about how we go back to the source, whether it's edge device in the field or a battery cycler in many of our customers' R&D shops and battery shops, and the integrators running a lot of battery cyclers as well. So John.
Yeah, well, this is good, actually, Manuel. The reason I'll mention is because when I look at kind of, questions here as we head into our Q&A segment, one of the ones I've already got in my hopper is, can you talk a little bit about battery cycler data? So it sounds like you're making a handoff that feels like we're building on stuff people want to know. So yeah, let's take it away, John.
Yeah, sure, Dan. So, battery cyclers, these are tools which take batteries and they charge them and they discharge them. And of course, there are many flavors of these battery cyclers, and there are many profiles which people use for this charging and discharging. So one of the core competencies which we bring to bear that companies don't necessarily have is to normalize, as we call it, this battery cycler data. So there are multiple manufacturers who might make it: Biologic, Arbin, MTI, Maycor, some of the ones that are known. Often people have homemade battery cyclers where they have a BMS system, which is a battery management system, which is substituting as a battery cycler system. So one of the core functionalities of our product is we take this data, and again, this is a large amount of data. It's not unusual for a company to have 1,000 channels or more where they have batteries hooked up to and are charging and discharging all day, each of these cyclers operating at 1 hertz or more. In other words, it's not unusual for us to go into a room that's usually very warm and smells like batteries, that's generating 1 million or more points per second to ingest this data, to associate this data, threading as we call it, with the serial number of batteries that were made a certain way because they're trying a new recipe, and then to make sense of it, right? So often we're finding that companies are a little bit overwhelmed. They sometimes plot too much of this data because they're not good at the feature extraction exercise, right? We see it charges and discharge, but what does that mean? Right, it's simple enough to calculate the round trip efficiency if it's an entire cycle, but often these tests are not done at an entire cycle because they're trying to mimic real world conditions like peak shaving, as we discussed before. So it's really quite a bit of what we do, and it's kind of the second or third building block which Peaxy and our software provide to companies so that they can do those bigger picture things which we discussed previously.
Yeah, you mentioned that some of them are not maybe as good at the feature extraction exercise. It's sort of overwhelming to some degree. What does that involve? Feature extraction is kind of this ML term. If I can put it in very terse business terminology, it's essentially understanding which are the subtle patterns, which are the sources of data, which are what's really indicative of something in the world that we want to lock onto, where we could actually get some predictive value and do something with it. You'd probably explain it better than I, John, but what is challenging about that feature portion that maybe you guys handle at a higher level?
Well, it's because the CEO wants a bottom line, right? The CEO wants to know, give me a score. My battery's an A, a B plus. And the CTO, wants to plot every point on a piece of graph, right? So we have to service both of those folks. So in order to give the CTO data, we just, of course, plot the data. We allow things to be drilled down. We have a hierarchy where you get the big picture, the middle picture, the low picture, and the lowest picture, right? For the CEO, we develop what are called composite scores. And this is a key benefit of using Peaxy, and you can see that here on the top left of this battery. This battery has associated with it typically tens of gigabytes of data. And we boil down that data and we give you that number, 79.3 out of 100. Now, how to go from 10, 20, 30 gigabytes of data to 79.3 depends on the technology, right? This particular type of technology is a battery which won't have the round trip efficiency that you might expect from an NMC lithium ion, but is safer, is less expensive to make, and therefore has a different figure of merit than simply round trip efficiency. Right, so that's part of the exercise which we do, is exactly that, to take the overwhelmed company that is this data. Perhaps the data is not threaded properly, perhaps the data is siloed in different parts of the organization, but we can bring it together and we can explain in very clear language how things are going. So this is a persona who's doing R&D that's trying to optimize a process, and they're 79% of the way there.
Got it. So it's just like you said, the CEO wants to say, give me a score. And it, as it turns out, it takes a lot of work to get us there. I've got another question in my hopper here coming in. It says you mentioned battery data tends to be higher volume than other forms of industrial data. How do you deal with this problem in terms of deciding which historical data to keep? You know, John just mentioned, Manuel, the overwhelming amount of this, and the CTO would like to put everything on a graph if he could. You know, we've got to make some decisions about, you know, what we're keeping. How would you respond to that question?
Well, generally, the trick is you don't know what queries you want to address to the data 5 or 10 years down the line. So our answer is we'll take the data that we can get. Moreover, the storage cost of taking in 100 or 200 terabytes of data is much more sensible now than it was five years ago. So the storage issue is largely resolved from a cost perspective. The tricky part comes is when you want to display 1 million points on a single plot. And that's when we have to get very creative around downsampling, because you want to make sure you see the transients in the graph, because this is electricity we're talking about. Things happen very quickly. So you want to provide the end users with the resolution they need, but you want to do it in a way that's sensible so that they can pull it, for example, through a web browser. It's very hard to display 1 million points through a web browser. So we've had to solve that problem in a very scientific way so that data plots can be made available at the resolution that they need to be available. And this is, I see Isaac here has pulled up an example of such a plot. So I guess that's one way to answer the question. And John, I know John's going to do a better job at describing what you're looking at here.
Yeah, that would be helpful. I like visuals here. John, if you could walk us through.
Sure. So this is an energy block, right? So batteries are built up into, well, cells are built up into batteries, batteries into strings, strings into blocks. Some folks call them containers. And a container might have on the order of hundreds of kilowatts to a watt of power. And a container might be able to sustain that power for an hour to 4 hours, right? To put things in perspective. So here is what we would call a cycle. We're defining a cycle as a 24-hour period. As simple as that sound, that's not how everyone describes a cycle, but for the purposes of this discussion, that's what we're doing. And we're seeing all of the main figures of merit on this particular battery block, which is composed of 6 strings for December 23rd, 2020. Right, so this is data taken every second. So each of these particular plots that you're seeing is made up of around 800,000 points, believe it or not. And you know, the report that we auto-generate for this company, this is 1/3 of that report. And these are generated every day and need to be traversed rapidly as they're reviewing how things are going. But this is what Peaxy brings to bear. You get the composite scores, if you will, these bottom line metrics at the top of the block. So we can satisfy the CEO mindset of saying, well, you know, what was my efficiency that day? Well, the energy efficiency was 63.83, as you can see on the second column, 4 rows down, right? Well, at the same time, satisfying the CTOs or the operators' curiosity, well, how did my temperatures change? Well, the temperatures were pretty well behaved this day, because on the bottom right, I see they went between 16 and 26 degrees centigrade. So there's not a lot of concern, and I'm seeing all of the temperature sensors, not just the average temperature sensor, because we know that when the fires do start, it's really just a few cells, which typically lead to fires that get out of control in these battery installations.
Cool. Well, this certainly helps in making things a little bit visual. And I think it's a good point to end on in terms of making some of the concepts we talked about tangible in terms of what do I see? When data is an asset, what does it turn into in front of my face that can help me steer decisions? That's, as a market research guy, I got to ask that question. And so I'm glad we got to touch on that today. I know that's all we have for time. For folks who end up listening to this now or in the future, feel free to use this as an opportunity to connect. Certainly you can find me, Dan Faggella, Emerj Artificial Intelligence Research on LinkedIn. Manuel and John Ervin are both here from Peaxy, who I'm sure are willing to connect with folks who'd like to learn more about the tech that they have. Manuel, anything you want to close out on today as a closing note for anybody who's tuned in?
Check us out is, I guess, what I would encourage our listeners to do. And we're approachable. We're a young, dynamic company. We love really big challenges. This is a team that's been well honed. We've served a lot of very interesting, cutting edge use cases, and we want to work with customers who kind of share our philosophy around data and the value of data. So if this resonates, I would just encourage the listeners to get a hold of us. Our email addresses are there, or you can find us online.
Excellent. All right. Well, thanks everybody for tuning in, and we'll wrap things up.
Yep, thanks, Dan.
Thank you, Dan.